Hi everyone, let's solve today's daily challenge, that is maximum depth of binary tree. In this question, we are given the root of a binary tree and we have to return its maximum depth. So binary tree is maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node, right? So we are given a binary tree, right? So let's say this is the kind of a binary tree that we are given. So we have to calculate its maximum depth. So its maximum depth will be the longest path, right, from the root node to the farthest leaf node, right? So that is if you go from here, then here, then here, right? So which is 3 in this case, right? So this is the longest path that you can get from the root node to the leaf node. Similarly, if you have a case like this, right? This is the binary tree that is given to us, and let's say we have another node here as also. So if you see its depth, it is again 1, 2 and 3. Its depth is also 3. Why? Because this is the longest path, right, from the leaf node, from the root node to the farthest leaf node, right? This leaf node is the farthest from this root node. So the question is pretty easy, right? Let's see how we will solve it. So how can we solve it? So basically we just need to go to the farthest leaf that we can find. So here what if we try to think about this problem in terms of recursion, so can we use recursion here, right? So we can use recursion. Why? Because if you see, let's say if you are at this root node, right, if it is not null, what we will do, we will simply return 1 plus 1 plus, that is we have got one depth, right? If the root is not null, we have got one depth, right? And then what we will do, we will make two recursive calls. First call will be to the left side of this tree and to the right side of this tree, right? So what, and out of these two choices that we have, we will return the maximum one, right? So here what will happen, let's make another tree and let's see how recursion will work here. So let's say we have a scenario like this. We have this kind of a tree. Okay. Let's also make some branches here and here, here, and from here to here. Okay, so we can clearly see that this is the longest path, right? So let's see how we'll find this out. What we'll do, we will do two recursive calls, right? So we will be doing, if the root is not null, right? If a value does not exist at this particular position, if it is null, then how can we go towards right or the left? So that will be our base condition. If the root is null, then we will simply return 0. Otherwise, we will move towards the left as well as to the right. And what we will do, we will simply return the maximum out of these two, right? So then let's see where will we move. So after at this point the maximum is 1 only, because we said now we'll add 1 plus this particular function call, right, towards the left and towards the right. So right now 1 will be the maximum value. Then what we will do for this particular call, right, we will again have two more calls, that is towards the left and to the right, right? So we will get 2 here and similarly 2 here. So what will be returning here, basically after all this, right, after performing this, we'll be returning 2 here, okay? Because we made first left call, we made from this node only, right, that is the root node. So everything will accumulate here only. Okay, then what we will do, then we will for this right node also we will do make two calls. So here also the maximum is still 2. Now here if you see, if we move towards right of this, what will happen, we will also reach this node, we have reached this node, and after this we will move towards left and right. So we can move towards left, so that is we will add one more one. So now the maximum here is 3, right? And here also if we see, it was the maximum was 2 only, but now the maximum has become 3, right? Let me take another pen. Then if you come from this we have calculated this. Now you will calculate this also, right? This distance also, because you will try to move towards the left, but that is empty, right? That is null, so 0 will be returned. But if you move towards the right, there is one node, so you will be adding 1. So what will you be getting? You will be getting 4 as an answer here, right? So that is the question, right? And that is how we will also be applying recursion. We can like apply recursion here, right? Now, so it's very easy question, right? So let's see what will be the code. So as I said, it's pretty easy. So the base condition for this recursion will be, we will simply return 0 if whatever node we are at, it is null, right? So we will check root. If it is null, what we will return? We will return 0. So this is the base condition of our recursion. And the other condition is, otherwise do what? If this particular whatever node we are at, if it exists, then move towards its right and left and return their maximum here, right? So what we will do? We will take the root. Okay, we will call this function, right? We will make a recursive call to this function. We'll say max depth, and we will say move towards the left plus 1, right? And also similarly we'll do for the rightmost part, that is max depth root of right plus 1. So after all these recursive calls, we will be returning the depth of the tree, right? That is the maximum we can get. See, we will only have two directions here, right? We can move towards the left or towards the right. So that is what we are doing here. So we will either move towards the left or towards the right, and we will simply add 1. So this is to add that there is one more depth, right? There is a node present at this depth. So for that we will be adding this 1. So let's quickly run it. Okay, so it's accepted. So that is how you have to solve this question.